Good day everyone, my name is Lekao Sanda and today I'll be presenting my project for CS302 with the Java Credit Count Management System. So this project demonstrates the application of core Java programming concepts, particularly object-oriented programming, exception handling, and user interaction through a console-based menu system. Throughout this presentation, I'll walk you through the objectives of the activity, the tools and environment I use, and a detailed breakdown of the two main classes. So we'll also explore the UML diagram, the key features of the system such as account creation, purchases, payments, and account closure, and how exception handling was implemented to ensure robust input validation. By the end of this presentation, you'll have a clear understanding of how the systems work, and how the code is structured, and how it meets the requirements of the activity. Let's begin with the objectives of the activity. So this slide outlines the learning objectives of the activity. So the project focuses on object-oriented programming concept in Java, including class designs, inheritance, polymorphism, and exception handling. It also emphasizes the use of arrays for managing multiple users and accounts. So the next slide, these are the tools required to develop the Java application. So we will use this NetBeans IDE for the writing and running the code, and GDK 10 or the higher is required for the compatibility. So the next slide, this credit class is one of the two classes that we're going to create. So this is the credit class. We will use it my surname, credit Sambat. So this class encapsulates the data and the behavior of a credit account. So it includes attributes for accounts, details, and methods to handle purchase, payments, and account closure. The constructor initiates the account with a random 4-digit number and assign a credit limit based on income. So this slide focuses on the credit class or the credits on the class, which is the core of our credit account system. So it contains 6 attributes. So here's the account number, client name, annual income, credit limit, credit balance, and is active. So let's discuss one by one for these attributes. So in the account number, we should randomly generate 4-digit number that uniquely identify each account. So it will automatically generate the 4 unique digit number. So next, the client name stores the name of the account holder, while the annual income used to determine the credit limit. The credit limit the maximum amount the client can borrow based on their income. The credit balance, the current amount the client owes. Lastly, is active. So this is the Boolean flag to indicate whether the account is open or closed. So the constructor initiates this value and uses 2 private helper methods. These are the methods. Constructor initiate accounts, make purchase, make payments, close account, get allowable purchase amount, and getters. So generate account. Create a unique 4-digit number. Determine credit limit, double income to assign the correct credit limit based on income brackets. So this is the public methods. So the make purchase adds the purchase amount and applies 3% interest as required for our activity. And make payment methods. So this is the double amount. Deducts the payment from the balance. And the close account, it means deactivate the accounts. Get allowable purchases amount calculates how much more the client can spend. So plus standards gathered for accessing private fields. So this class encapsulates all the logic related to a single account. So the next slide, this is the client Sambat. So this is the class design. So this class serves as the main driver of the application. So it contains the main method and a menu-driven interface for interacting with users. It manages an array of credits and bank objects and includes methods of each menu option. All users' inputs are validated using exception handling to ensure robustness. Now let's look at the client Samba class, which serves as the main controller of the application. It contains the main method and handles all user interactions through a menu-driven interface. So the class manages an array credit subject objects. So the key methods includes create new account, credit inquiry, make purchase, make payment, and close account. So let's discuss the create new account first. So this is the prompt the user for name and income. So validates the eligibility and creates a new account. While the credit inquiry so allows the user to check their account details. Make purchase validates the account and purchase amount, then update the balance with interest. Make payments, accept the payment, and updates the balance. And lastly, close the account. Check if the balance is zero before allowing closure. Then find account. Search for an account by a number and ensure it's active. So all input is validated using the try-catch blocks to handle exceptions like invalid numbers or out-of-range values. This ensures the program is user-friendly and error as resistance. Next slide. So this is the UML diagram. So they summarize the structure of the two main classes. Credit Samba contains the data and the logic for individual accounts, while Client Samba manage the application flow. The diagram shows attributes and methods for each class, illustrating the responsibilities and interactions. This UML diagram visually summarizes the structure and relationship between the two main classes. On the left, we have the credit summary, showing private attributes and public methods. On the right side, client summary manages an array of credit summary objects and contains the logic for user interactions. Thus, this diagram helps us understand how the system is organized and how responsibilities are divided between data handling and user interface logic. It also reflects good object-oriented design principles, such as encapsulation and separation of concerns. So, in the next video, now that we covered the structure, logic, and features of the Java Credit Account Management System, the next part of this presentation will be a video demonstration. In this video, I'll walk you through the actual programming running in the NetBeans IDE, showing how each features work in real time, starting from account creation to purchase, payments, and account closures. This helps you see how the code translates into a working application that follows the program's specification exactly. Let's proceed to the demo. So here's the required for our activity. So we have these items to be shown in the output. So this specification. We have to create the account and acquire the credit, purchase, and make payment, and close the credit account. And we can also exit or terminate it. So these are the specification and requirements to run the code. So let's go to the NetBeans itself. So are the two main classes that we created, the client symbol and the credit symbol. So as you can see in the client symbol, you can see the methods and attributes that we use. Okay, and while the credit symbol, same as this, there's also you can see the methods and attributes that we use. You can see that. And after that, we can try to run it. We can see it is run correctly. So it should be shown the exact items that activity requires. So that is how. So it runs. It runs successfully. So let's match these items if it is correctly. So that is, as you can see, only the indent here is the problem, but it's okay. At least we have the items required. New credit account, credit inquiry, purchase, payment, and close the account. And exit. So let's try the program specifications to run this program. So let's type the one. So new credit account. Let's type one because it's there. Type one and enter. Next, the client name will be there. So we would use my name to create the client name. Then enter. Next one will be the annual income. So as the required, we put annual income to assign the. So we will take the range for this one to 100,000, greater 300,000. Okay, so let's say we will use 250,000. So let's use 250,000 to get the limit, credit limit of 30,000. So you can see that one. See the result. From credit, it will show there. Our account is already created, and the credit limit is 30,000. So we can run successfully for this first item to check. Okay, what's happened? Uh-huh. Let's go back again. Okay. Mhm. So let's go to the credit inquiry. So the credit inquiry is in the second item. So let's type 2 and enter. Enter the account number. So we generate the 4-digit. So we will write there and enter. And we will see the account that we already created and shown there. So it runs perfectly. Mhm. So let's go to the purchase. So purchase, okay, so let's type 3 and enter. Of course, enter the account number, the last 4 digit, okay, and enter. Then, what is the required there? It's less than 1 and greater than itself. So, okay, let's say, then let's go to the payment because we use already the credit already purchased for amount of 100 real. 100, okay, so let's pay the credit. So let's say we're going to pay what we took. Okay, let's say 100. So I think there will be a balance of 3, something like that. So let's try it first. Still we have to pay 3. So let's pay it again to make it 0. That one, the 3, we have to pay that amount. Before we close the account, we have to pay that amount. So 3, we have to pay that amount. Now it's closed. We paid that already, so we can close it. See, let's type yes. So, so account was closed successfully. So it runs perfectly. So after we close the account, the last requires the exit, so we can terminate the program. Okay. Exit. That's good. Exit perfectly. So that's it. So we exit. So, to conclude this project has been a comprehensive exercise in applying core Java programming concepts in a real-world scenario. Through the development of the Java Credit Account Management System, I was able to demonstrate the use of classes and methods, implement the inheritance-ready as structure, and manage multiple users using an object array. I also ensured that all users' inputs were handled safely and effectively using exception handling, which is crucial for building a reliable and user-friendly application. The system supports essential credit operations such as account creation, inquiry, purchases with interest, payments, and account closure, all through a menu-driven interface. Overall, this activity not only strengthened my understanding of Java, but also gave me practical experience in designing and implementing a complete application from scratch. Thank you for your time and attention. I'm happy to answer any questions you may have. Would you like a version of this video or presentation? Just give me a check. And that's the end of the slide.